Assignment 6. So up to this point, you have been looking to storing a lot of the data that you've been generating. Most of it has been on the server side, right? We haven't actually been storing it in anywhere persistent state, right? So that any information that you might have generated on the server side, it was only stored in the CPU, in the RAM, right, of the running server. If the server rebooted, all that was gone. Obviously, we need to have a more permanent storage of that data. And so we covered last week. We talked about JPA as a mechanism for storing that data into a persistent relational database of using JPA. Java Persistence API that allows you to create a Java model for storing that information in a relational database. So the assignment for this week is to use the same data model that you already worked on in the previous assignment. Right? Use the same exact data model to now map that to relational tables. Right? You're going to annotate the users, the faculty, or the courses, the modules, the topics. You're going to annotate them as entities, as JPA entities, and have them persist to a relational database. Right? The only part of the data model that I believe you didn't work on in the previous assignment was widgets. Is that right? Right. The widgets were hard coded. Still on the client, right? So this assignment will ask you to, you've already worked on the data model for courses, modules, lessons, topics. So this assignment asks you to do the other, the remaining data model, which is the widgets data model, okay? And implement the use cases that you have of being able to create a new course, create a new module. Right now, you're going to web services, and those web services are storing all that information in memory. Right? So instead of storing it in memory, what this assignment asks you to do is to replace all those for loops, all those hash tables or lists or collections that you have been doing in memory, right? Replace that by annotating the Java model with JPA entities. The API should stay the same. The REST API, you should not have to touch that. Right? That should stay the same. The client should stay the same. The client should not care that the data is coming from either memory or coming from a relational database. Right? You should only have to focus on mapping the data model. Right? Actually, a lot of those for loops, that's going to be pushed into the database. The database is going to be doing all that looping, all that matching. Okay. So the data model that you already have, right? You already have some of this here, like the topics, the lessons, the courses, the modules. That you should already have. Right. The difference might be that you'll need to annotate this as entities. You might need to annotate also the IDs. If you have primary keys, you'll need to annotate them as IDs and as auto increment. You'll need to annotate that course and module have a one-to-many relationship. That module to lessons has a one-to-many relationship. And that lessons to topics has a one-to-many relationship. Right? And topics to widgets has a one-to-many. Right? You'll also need to annotate that widgets to list widget, all these are inheritance relationships between the widget, right? I think the strategy that we decided on was the what was it? What did we decide? Single table? Yeah, single table, right? Yeah, or the denormalized schema, right? The denormalized schema. So that will simplify the schema quite a bit. So this is the UML for what we're building. You'll need to have repositories for each one of these. Most of these will be just a 3-liner piece of code. So this should take you, I don't know, like 15 minutes to do this part. These are just boilerplate They all look the same, right? They all extend the CRUD repository. The only difference is perhaps the name of the repository and parameterize to persist either the course or the module or the lesson or the topic, right? And what you don't have from last week, from working on the previous assignment, was a service for the widgets. Okay, you worked on the services for the courses, the modules, the topics, right? You worked on that on the previous assignment. This one asks you to create the web services for the widgets. Right? You might get away with, I mean, depending how you build a client, you might be able to get away with a single service. But again, depending on how you built it, you might need to create dedicated services for each one type of widget. Depends how you built it. If you can get away with one, that's fine. Right? You can leave it at that. But again, depending how you implemented it. Some folks were doing a lot of caching on the client side. Some folks were loading the entire course and with all the modules and all the topics, all the lessons, and then caching that on the client and doing all the operations on the client, and then doing one huge post or one huge put. Other folks were doing individual retrievals, right, of the individual topics, individual modules. So it depends on which way you went. You'll be able to go simplify this or not. Anyway, so the web service for the widget should allow you to create a new widget, retrieve all the widgets, retrieve an individual widget, update an individual widget, or remove an individual widget. Okay, and again, depending on how you implement it, you'll need to also implement the list, the paragraph, and the heading interfaces for this. Okay. On the client, you should already have client services for the module, the topics, the lessons. You should already have that. This asks you to create a client service, but for the new widget, right? The new widget data model. Okay. You'll need to refactor Redux so that now instead of using a client-side Redux state of the list of widgets, instead fetches the state from the server, right? And updates and initializes the Redux state from the server as opposed to having it hard-coded. Right now it should be hard-coded on your implementation. Right now it's no longer going to be hard-coded. It's going to read it from the server. Okay? All right, any questions? So basically is integrate with JPA, right? So that things are now stored permanently in a relational database as opposed to hard-coded or kept in memory. All right. So this we'll make this due maybe next Wednesday as opposed to next Monday. So we'll give you a couple more days. Yeah. Any questions? Yes. Yeah. So right, it would be a hosted database. Yeah. So if you're doing AWS, I'm sorry. Yeah, Heroku has a what is it? JavaDB and has a ClearDB. Has a couple of free databases. If you stay under a gig, it's free. Yeah. Any other questions? And I'll provide plenty of examples on how to implement some of this, right? So that you can build on that.